My research tries to answer the question, what's really inside a black hole? A black hole is a region of space where gravity is so strong that nothing can escape, not even light. Since nothing can escape from inside a black hole, anything or anyone we send inside would never be able to return and tell us about it, leading us to say that anything can be inside of a black hole. But I'd like to try to answer this question a bit more precisely. Now, inside of a black hole, gravity is so strong that things get crunched down to a scale where quantum mechanics becomes very important. Therefore, a complete description of a black hole requires a theory that combines both quantum mechanics and gravity, or a theory of quantum gravity. For my research, I use a theory called Euclidean quantum gravity, which is based on something called the principle of least action. We can understand this principle through the analogy of rolling a ball down a hill. Imagine you have a landscape that looks like this brown curve with peaks and valleys. Your intuition tells you that if you send a ball into the landscape, eventually it will settle at one of the three valleys. However, if we allow for quantum effects, what can happen is that a ball sitting in one valley, let's say this blue ball, can momentarily borrow energy from the vacuum and tunnel to a lower valley. Therefore, the correct quantum description of the ball is that it settles in the lowest valley. This is exactly how Euclidean quantum gravity works. We can construct a landscape that's appropriate to black holes, and the quantum state of the black hole is described by the lowest valley. Now, doing this in full quantum gravity has eluded physicists for over 80 years, but restricting to a specific class of black holes and making tons of simplifying assumptions, we can actually make some progress. So I did this after about a year and a half, and was able to compute the landscape of the black hole, which looks like that. It has three valleys. The first corresponds to nothing inside of the black hole. The second corresponds to a black hole whose interior looks like the surface of a donut. And the third corresponds to a black hole whose interior looks like the surface of a pretzel. Now, as drawn, the valley corresponding to a black hole with the surface of a donut is the lowest, and therefore that's the correct quantum description of the black hole. However, as we tune certain parameters in the theory, we change the relative depths of these valleys, thereby changing the quantum description of the black hole. And here we have a surprise. Preliminary results suggest that for no value of the parameters is the valley corresponding to the pretzel interior the lowest. This means that the inside of the black hole never looks like a pretzel. So it's simply not true to say anything can be inside of a black hole, because it can never be a pretzel. In this way, we're learning some of the surprising things that quantum gravity tells us about our universe. Thank you.